I have my old arcade cabinet project. This was going to be like an 8-bit screen, and there was previously a controller here, but no longer is there a control pad that was literally mounted by paper. I had an Arduino Mega running it that had some basic arcade games like Snake on it. It had an RGB screen of, I believe, 16 by 16 pixels. See that there's like mouse crap in there, and the fan that was in here is missing. I laser cut this, by the way, years and years ago at the first space that we had for Novolab. Brings back some memories, but yeah, you can see the absolute state of this thing is not great. These switches aren't wired correctly. Obviously nothing turns on. This stuff doesn't work anymore. That's literally an exposed power supply that I taped with Scotch tape to the side of the thing. Yeah, this is just a disaster. Anyway, we're gonna have a look at the screen. One of the wires straight up came off the screen. Great. So yeah, this is the screen. This is from a local company called Wyolume, I believe. So yeah, you can check them out there, I guess. Yeah, so this is, I believe, 16 by 16. This is actually made up of 2 panels that are glued together and held together with popsicle sticks, which actually, this worked super well and has held up all these years. You can see this soldering job is actually pretty good. The 5-volt and ground connections there. This can be wired in series or parallel. Yeah, there's no controller or anything on here. It's just the lights themselves. So those are probably WS 2812s or something like that. And there's some variant of smart LED lights where the controller is built in to the light itself. So they're wired in some kind of series or parallel pattern depending on how you set the solder pads. And this wiring is an absolute disaster. I'm just gonna be desoldering all of that. It's this really awful stuff too that sticks and holds its position. Look at that. No, just no. Also, there's tape all over this thing. This was also poorly taped on only one side. This is made of paper. This is actually pretty neat. These are laser cuttable light baffles. You put them on and it helps project the light in a clear manner onto a screen. I did clean this up a little bit. Love that thing. Portable, rechargeable compressed air. Really great. So at least there's not spider webs all over it anymore. But it's still not in a great shape, so we're gonna have to fix that. Soldering job is literally the worst. Some of these aren't even attempted to be soldered. The solder didn't even stick. Apparently one of the wires is missing there, because that was there earlier. That just came out. We have one of my worst nightmares. Unremovable label goop. This is why I hate cellophane tape. Luckily, we do have some alcohol here, so I'm just gonna pour a little bit of that. Okay, that was a lot more than a little bit. And we're gonna use an ESD-shaped brush here. Just kind of brush that around. Actually, we're gonna brush this all around the whole thing, because I poured too much anyway. Okay, so we have a bunch of random junk here. I want to try and fix that. But this time I'm going to try and be a little more careful with pouring it. I need a better application method. You can see that kind of does clean it up, but not super well. Also going to try and take care of this spot over here. And that's the power connection, so I'm going to reuse that. Well, I'd say that this is looking a lot cleaner than it was before, for sure. It's totally smooth and shiny again. And there's not any label residue. Oh, there's a little spot there I still gotta get. And there's no tape on it anymore. It's not covered in spider webs and hair from our old dog, so that's nice. You might think that my previous soldering job on here was really, really bad, and you're not wrong, but I don't really blame myself that much for it, because the thing is, this arcade machine project that I did originally, that this is from, I did that when I was 12. I was doing stuff with the Arduino and coding my own versions of arcade games and stuff when I was 12. I have definitely been into electronics for a long time. And I've also wanted to do a YouTube channel for a long time, so this is kind of a dream come true, even if there's only a couple of you guys watching. It still means the world to me, so I'm glad you're here, honestly, because I've really wanted to do this for a long time. So that's why I'm trying to do something a little bit special, at least as special as my dumb butt can think of for the holidays. And there you go, that's nice and cleaned up. Hopefully that's some satisfying cleaning up ASMR content, because that's very profitable, I hear. All I gotta do is buy a fake Nintendo and completely destroy it with a hammer and then record in reverse as I quote-unquote fix it. This is actually cleaned up and not being recorded in reverse. Yeah, I guess next we're gonna have to look up the part number for this and see if we can figure out how to actually wire it. And I'm probably going to go for serial mode because it's less wires than parallel mode. At least if these are NeoPixels. NeoPixels can handle a very high data rate, so it should be able to drive. This is only 16 times 16, so 256. Honestly, that shouldn't be that big of a deal. They're like 800 kilohertz. Again, assuming these are NeoPixels. I actually have no idea. Obviously, it's not like they're labeled, but I can see that these have 6 pins, so I'm not sure which WS, which stands for World Semi, by the way. That's the company that makes NeoPixels. I'm not sure what model these are. They might not even be NeoPixel brand. They're clearly smart pixels of some kind, but I just don't know what they are. Now, the WS2812B ones that are popular, those, they only have 4 pins. These have 6 pins, so they're not that. They're something else. Now, they might be the older model, WS2811. That's what we're going to find out when I look at the datasheet. Okay, so here we have the Wyolume TIM, which apparently stands for the Intelligent Matrix User Guide, and this is on Google Docs. So yeah, that's a sign of quality right there, I think. Oh, interesting. It's got the schematic. I don't need to look at that, but that's interesting. What we need, actually, is, first of all, specifications. And you can see the input voltage is 3.3 to 5 volts. The current is actually also helpful, about 2.6 amps. And that's per board. We have 2 boards, so that's going to be 5.3 amps. They are WS2811 RGB lights, so they are, I was actually correct, they aren't the 2812B, they are the 2811, the previous version of that. And uses are large format displays, mood lighting, holiday lighting, and super bright full color world clock. That's an oddly specific use, but alright. We're actually going to be using it for this use case here. And parallel data in and out, and serial data in and out. Here's what I wanted to look at. You can solder bridge the links using the trapezoid pads. Oh, you can mount a dual row header, and then you can use jumper links. Interesting. So I looked through the data sheet, and there wasn't really very much mention of how fast the boards can actually update in serial versus parallel mode, but it did kind of mention that parallel mode is more if you're using larger arrays. And I'm only using 2, so that's not really a very large array, so knowing my past experience with NeoPixels, I think it'll probably be fine to run only 256 pixels off of 1 pin, or even 2. I can use 1 for each board. I was like using all of the parallel connections, and I think that's just completely not necessary to use that many pins. All we need is like 60 hertz throughput at most. We can probably even get away with 30, and I think 60 hertz should be easily achievable with 256 pixels at the high refresh rate that NeoPixels can update at. And we should easily be able to get 60 hertz out of a single pin. What we're doing right now is we're going to be connecting these shorting links for serial TIM. Those ones. Now first I'm going to tin my soldering iron because this tip is not as healthy as it once was. It really needs to be tinned more frequently. Ooh boy. Doing this thing on me where they don't want to connect. I didn't know that this would happen. Yeah, getting these kind of pads to short out is always really annoying. And there's a bunch of them to do, so Yeah, see how it's really easy for these to undo themselves while I'm messing around with the soldering iron? Now, the reason for that is because, as I always say when I'm teaching soldering in my classes, hot metal is attracted to hot metal. In fact, metal is attracted to metal in general. So, the thing is that the solder wants to stick to the other metal on the circuit board, and it doesn't want to stick to this stuff. This is called the solder mask, and it's called that because it masks the solder. It specifically repels solder, and most surfaces that aren't metal already repel solder, and this stuff is especially designed to repel solder. Getting these connections to short out across the solder mask gap that's between them is really annoying and difficult, because this stuff is specifically designed to repel solder, and you're trying to get it to not do that. So see how much I can run it between, and the solder just keeps going back and forth instead of wanting to go across the gap to make the connection. So we are trying to get these connections to bridge without making them bridge to the places that they're not supposed to bridge to. Bit annoying to get it to do that. Hoo boy, that is a disaster. You know, I'm not gonna lie, I didn't expect this part of the video to take this long. But that's how my plans always go. Things take longer than I thought they would. And the part that I thought would be the hard part turns out to not be the hard part. Turns out to be a different part. Now, how are we going to clean this up? We're going to use some more alcohol. It's alcohol time. Now, I would actually like to find if there's a more effective way to clean up solder gunk than alcohol, because alcohol really isn't super effective. It does work eventually if you keep scrubbing, but I feel like it's not that much more effective than water. But alcohol does have the advantage that it's not really conductive, so you can just pour it all over your circuit board, and it basically just evaporates eventually. It just goes away completely, and it won't, cause issues for you. If you spilled water all over your motherboard while you're trying to clean it with water, that wouldn't end well. I mean, I've spilled water on my motherboard and it didn't end well. I've done a lot of water cooling with PC builds, so yeah, I am aware of what happens when you spill water on your motherboard. The method that you're supposed to do if you spill water on your electronic switch is make sure to dry it as quickly as possible and then leave it to air dry for several days without attempting to turn it on at all. Do not try to turn it on again for several days. I then actually had blue screens for a while after that, but I just realized that was because my Intel CPU was not seated correctly and not because I spilled water on the motherboard. Now you can see the arrows are facing the same direction here, so I believe that means that I put the panels together in the right orientation. So basically I should be able to do exactly what I did with the power wires, which I might do those with the power wires on the other side, by the way. I believe that I should be able to just connect that. Yeah, I guess the out for H just goes into A. Yeah, there you go. A, B, C, D, E, F, G, H. A, B, C, D, E, F, G, H. So if you come out of row H and you go into row A, then basically you're coming out the end and going into the next one. Now, question is, why are there two of them? Because if I recall how NeoPixels work, there's only one pin that's the data pin that controls everything. There's no clock line. So I don't know why there's two pins here. That's what multimeters are for. It's for testing things. So we're just going to check if this is on continuity mode. Indeed. Huh, would you look at that? In fact, not only are these for continuity, but we have, for some reason, two sets of two pins that are all exactly the same. Like, all four of these are the same pin. I don't know why you would ever need four of those, but, well, you get four. Okay. I'm just finishing up the wiring for this metal one. Okay, there we go. So you can see that connection came out pretty good. Right, so I have also soldered these on, so we now have ground and 5-volt power on that side and on this side. So that should just get a little bit more power flowing through the board. It's looking nice and clean on both sides. The solder joints are pretty clean. So yeah, the only thing that should be left is to attach power to the top somewhere here, and our serial data in. A. As usual, the first test that we're going to run on the board is the NeoPixel strand test. So that is down under examples and Adafruit NeoPixel, and then we go to strand test. So that's exactly what the name implies. It's a strand testing application. First thing we want to change here is LED pin 6. I think we can leave that on 6. LED count is 60. That will be 256. Or actually, we can even just code this as 16 times 16. Now, COM port. I have 3 COM ports, 3, 4, and 8. I don't know which it is. So we're just going to hit upload and see if it uploads. It's compiling right now. And it says uploading. And it looks like we're having some blinking lights there. It says done uploading. Oh, okay. Then next we connect the pin here. I've got the power wires and the data wire connected here. So we're going to connect this, the data wire, to pin 6, which is that one. Oh, we need a common ground, so I'm going to connect these both to my power supply. But because we need a common ground between this and the power supply for this, I am actually going to get a breadboard wire, a random one here. We're going to put that in there, just kind of stuff it into the same alligator clip, make sure the connection is solid. Adjust the angle up. There we go. All right, now it has I have a few different settings programmed in here. 5 volts is what we want. And I'm going to turn this up to 500 milliamps to begin with, although I believe it can use up to 5 amps. So it can actually go quite up there. Luckily, this power supply is quite capable. I think if this model can do like 10 amps, so we can power this whole thing off of this power supply easily. Now I'm going to turn off my light there so that we can see everything clearly. And we're going to, whoa! It's in the middle of its strand test. Well, that certainly looks like a functioning display to me. It looks like the signal is getting through, and I don't see any weird glitching. Even when I move it around, I don't see any glitching, so that's good. And actually, look at that. We are up to that 0.5 amps easily, 500 milliamps. We're on current limited mode, so I'm turning this up slowly. Let's go to 2 amps. We're going to wait for that to settle, and then it's going to start showing the readout. So yeah, 900 milliamps is what we're currently looking at here in terms of power. Gets pretty bright too. Weirdly, it looks like the displays are driven kind of upside downy. Like you can see that they start here as the first pixel, and then it goes down, but it then spills over to the top half there. So we're going to have to remember to change that when it's driven in software. Okay, here's my code so far and what it does. It's showing 2023 with the little fireworks in the background. Fairly simple effect, but you can't really read the year because it's going by too fast, so I think I have a solution for that. Also, here's my code so far. It's already getting long. It's 100 lines long, and that's just the code for the main part. I had to write some custom code for the matrix control because of the weird layout with the bottom half and the top half being in reverse order and stuff like that. But now the matrix works and the pixels are coordinated with the correct coordinate system, where this is the pixel 00 in the top left, as is standard for all displays. It's based on like how CRTs drew from left to right and top to bottom with the electron gun. Yeah, because of how CRTs drew the image with their electron gun starting in the top left corner. All displays since then have been addressed in the top left corner being pixel 0 and going down and right. Point is, it is now configured to do that, but you can't really read the year. It's going by too fast. There we go. That's a little more readable. 2023. 2023. Although it could also be 2320, but I'm pretty sure that it's not 2320. Besides, it's not any less confusing than those weird sunglasses they wear with the year on them. Those get dumber in their design every year, I swear. Anyway, Happy New Year. So I'm trying to set up a countdown, and it's doing this. It's only flashing it the number for a second. That is entirely accidental, and just a bug in my updating speed code. But it actually looks pretty damn cool. So I don't know if maybe I should keep that. And hey, the automatic centering code works. It centers the single digits correctly. Let's see what it does. Oh, well, it got stuck at A. Never mind, several minutes later it has moved on to P, which actually, that kind of tells me what might be wrong. I believe that the issue is that we're having an overflow bug. That would explain why it took several minutes to change letter when it's only supposed to take a few seconds. Okay, so right now I'm just uploading the final version. Now I can set a timer, like for example, if I want to count down from 12 seconds. There you go.